Welcome to the Flutter Interview Questions and Answers series. In this video, we'll cover key FlutterFire topics like user authentication, Firestore data handling, real-time updates, image uploads, offline persistence, and push notifications. Question number 1. How do you implement user authentication with Firebase in Flutter? To implement user authentication in Flutter using Firebase, the Firebase_auth plugin is used, which provides APIs for user registration, login, and session management. First, add Firebase to your Flutter project and include the Firebase_auth dependency in pubspec.yaml. Then import it in your Dart file. Next, create an instance of Firebase auth like this. Final Firebase auth_auth equals Firebase auth.instance. You can now perform basic authentication tasks such as sign up, sign in, and sign out using _auth variable. The code registers a new user in Firebase Authentication using an email and password. The create user with email and password method is called on the Firebase auth instance to register a new user. It takes two parameters, the user's email address and the user's chosen password. On successful registration, it returns a user credential object that contains the user's authentication details. Question number 2. What are Firestore data types and how is data structured? Firestore organizes its data in a hierarchical structure of collections, documents, and fields, rather than tables and rows like traditional databases. Each collection contains multiple documents, and each document holds one or more fields in key value pairs. A collection acts as a container for documents. For example, a collection named users might contain several documents, each representing an individual user. Documents are lightweight JSON-like objects identified by unique IDs. They hold fields, where each field represents a property or piece of data about that item. Each field can store values of various supported data types, including strings, numbers, booleans, timestamps, arrays, maps, and references to other documents. You can even have subcollections within documents, allowing nesting of related data structures, such as each user having a subcollection of orders or messages. Firestore is schema-less, meaning documents in the same collection can have different fields and data types, though consistent data structures are encouraged for easy querying and management. Question number 3. How do you listen to real-time updates in Firestore? In Firestore, real-time updates are achieved using streams provided by the snapshots method from either a collection or a document reference. Whenever data in Firestore changes, such as when a document is added, modified, or deleted, the stream emits a new snapshot automatically to update your app's user interface. To listen for real-time updates to a Firestore collection, use the following code snippet. This creates a stream of snapshots that continuously listens to the user's collection. Each snapshot contains a list of documents representing the current state of the collection whenever a change occurs. Question number 4. How do you upload an image to Firebase storage and save its URL to Firestore? To upload an image to Firebase storage in a Flutter app and save its download URL to Firestore, you typically follow these steps. First, select or obtain the image file, for example using the image_picker package. Then create a reference to the location in Firebase storage where you want to save the file, usually organized in folders like images or user_images. Use the put_file method to upload the image file asynchronously. Once the upload completes, get the file's public download URL using getDownloadURL method. This URL can then be saved in Firestore as part of a document, so your app can later retrieve and display the image. This approach cleanly separates storage, for large binary files like images, and Firestore, for structured app data, while enabling easy retrieval of images via their URLs in your Flutter app. Question number 5. How do you secure Firebase data? Firebase data is secured using Firebase security rules, which define when and how users can read or write data in Firestore, real-time database, and cloud storage. These rules act as a protective layer that checks each request against specified access conditions before allowing it to interact with your data. A basic security rule ensures that only authenticated users can access their own documents. The following example illustrates this rule. This rule means that a user can read and write only to the document in the user's collection that matches their Firebase Authentication UID, effectively isolating each user's data. Security rules can also check roles, custom claims, or specific field values to implement attribute-based and role-based permissions. For example, admins may have global write access, while regular users are restricted to their own records. You can also validate data types, field presence, and invariants to prevent malicious or invalid writes. In essence, Firebase security rules protect your database by combining authentication checks, data validation, and hierarchical matching of paths through match and allow statements. Properly written rules ensure that only authorized users can access or modify data, keeping your app safe from unauthorized access. Question number 6. How do you enable offline data in Firestore? Firestore automatically supports offline data persistence, meaning it keeps a local cache of data your app reads or writes so that users can still access it when their device is offline. Once the connection is restored, Firestore synchronizes local changes with the cloud backend. By default, offline caching is enabled on Android and iOS. However, it must be explicitly enabled on the web and can be customized in Flutter. To manually enable or configure it in a Flutter app, use the following code block. This ensures that data your app interacts with is stored locally even without internet connectivity. It also allows users to read, write, and query the cached data while offline. Firestore also provides the isFromCache flag and snapshot metadata to detect when data is being served from the local cache instead of the server. This helps developers display appropriate UI feedback, such as showing an offline indicator or notifying users that they're viewing cached data. When the device reconnects, Firestore automatically merges updates by applying the last write wins logic, ensuring a consistent and synchronized state without losing local changes. Question number 7. How do you send push notifications using FCM? To send and receive push notifications in Flutter using Firebase Cloud Messaging, the Firebase_messaging plugin is used. FCM enables real-time message delivery to devices across Android, iOS, and web platforms. Step 1. Add the required dependencies like Firebase_core, Firebase_messaging to pubspec.yaml, then run Flutter pub get to install them. Step 2. Initialize Firebase and request permissions. In your main.dart, initialize Firebase and request notification permissions from the user. On iOS, this step prompts the user to allow push notifications. On Android, this typically happens automatically. Step 3. Handle incoming messages. You can listen for messages when the app is active, in the foreground, using the Firebase messaging.onMessage.listen method, as shown in the following code. To handle background messages, when the app is minimized or closed, use the Firebase messaging.onBackgroundMessage method. Step 4. Retrieve the device token. To send targeted notifications, retrieve the device's FCM token. This token uniquely identifies the app instance and is used when sending messages via the Firebase console or HTTP API. In summary, FCM in Flutter works by requesting user permission, listening for messages in real time, and linking a unique device token to send targeted push notifications effectively across all major platforms.
Thanks for watching. Don't forget to like and subscribe for more content.
You made it to the end, awesome. If you learned something new today, give this video a thumbs up and subscribe to Crafted Scripts for more practical coding guides and developer tips. Stay creative, keep coding, and I'll catch you in the next one.